All right. Thank you, everybody. This is the September 2025 installment of the Microsoft Business Continuity Virtual Group. With me today, old friend of mine, co-lead of the group, Rick Lowe. He's going to be talking about moving from Microsoft SQL Server to Postgres SQL, talking about high availability and disaster recovery. So with
Mhm.
that, turn it over to Rick.
Hey, everyone, thanks for joining. Um, so yeah, as David said, I'll be talking about moving from, be talking about high availability essentially. The title of the talk is moving from SQL Server to Postgres, HANDR. However, it's kind of a level set. A few things I should say up front. First of all, for the purposes of this particular talk, I'm not really trying to present myself as a Postgres expert. And kind of the audience I have in mind for this are people who have been doing SQL Server for like, 5, 10, 15 years, whatever. Their bosses are on them to learn more about Postgres, and you're just kind of wondering, what kinds of things are going to seem really, really messed up when you start working with Postgres. Um, the other thing I should mention is, to some extent, I maybe should have called this talk, you know, uh, high availability and disaster recovery for Postgres. You might be getting ready to do it wrong. But by which I mean one really, really big difference, in my opinion, between how SQL Server does this stuff and how Postgres does this stuff is in the SQL Server world, and I'll mention this a few times through the talk. In the SQL Server world, we're kind of used to not seriously considering some of the platform as a service cloud options, like Amazon RDS or yeah, it's obviously better on the Microsoft side, but even some of the Azure offerings like Azure Database or Managed Instance aren't seeing the utilization you might expect just because SQL Server has had such a kind of like long sort of incestuous relationship with Windows. And there's always like one specific feature you need that kind of keeps people from doing the platform as a services approach. Um, that's not really the case with Postgres. The past offerings are actually really, really, really good. And if you use them, you don't really have to worry about this stuff. So to some extent, I just think this talk perhaps is intellectual curiosity to some extent. Everyone's still here. That's like your cue to, I was just kidding. A little bit about me. My name is Rick Lowe. I'm one of the co-leaders for the group. Um, please, so of course, feel free to ask questions through the talk, but also, especially if you're reviewing this after the fact online, feel free to shoot me an email saying, hey, I had a question about your presentation. I'm an independent consultant for SQL Server, mostly, also obviously doing some Postgres, currently based in Washington State, and I'm a Microsoft Certified Master for SQL Server. So, as I said, my audience for this is really SQL Server people who are kind of wondering like what's going to seem goofy as you move into Postgres. So kind of towards that end, I want to do a review of what we're used to dealing with in SQL Server, if you'll kind of bear with me through this. Um, and there's actually quite a few options. The first one I mentioned, mostly for completeness, or mostly because people keep trying to mention this as an option for high availability, and it really, really is not. But because it comes up, I should say replication. Um, or if we're getting more precise, um, specifically logical replication in SQL Server. Um, I mean, full stop, I would say this is not suitable for high availability. You never see it done that way. And it's also almost never used for disaster recovery today. In the past, that is maybe a slightly different discussion, but nowadays you don't see replication used as much. Um, the one situation where I've seen someone kind of use it is when they really genuinely only needed a couple tables from something. But yeah, this just isn't a thing. It's mentioned mostly for completeness. And setting aside, there are a few issues with replication. Um, but I mean, setting aside some of the harder ones to explain, kind of the deal killer with this stuff tends to be that there's no automatic failover. So if you're talking about high availability, that's usually kind of a key feature is that you don't have to be there to fail over when something goes wrong. Um, so kind of going up the stack or forward in time a bit, there's log shipping. That kind of literally just means you're just taking your transaction log backups in SQL Server and shipping them off to another instance and reapplying them. Now, again, that obviously doesn't work for HA because there's not really an automated failover option, but it's fine for DR. I would actually say it's really, really good for DR to some extent. I think we get such tunnel vision with availability groups. I would almost argue log shipping might be kind of underutilized in some situations because it can be a little bit more robust for certain kinds of failures than availability groups are. That's literally a different talk. I probably shouldn't have gone down that rabbit hole. Um, but yeah, it's also available in pretty much all editions. Standard log shipping, which is basically you can click through your wizard and set it up version of this, is available in standard edition without any issues. You don't need enterprise edition. However, again, there's no automated failover, so this is really a disaster recovery thing, not a high availability thing. So at this point, we start getting up into the things that actually could be used for high availability. Database mirroring isn't really as much of a thing anymore. This is really, really, really cool back in about I think it's like SQL Server 2005 or so. Technically, this feature is deprecated. However, I don't really see Microsoft turning it off anytime soon. It still works. And more importantly, it still works with standard edition. The big catch here is database mirroring is very much at the database level. So if you have 10 databases on your instance and you need them to fail over as a group, it's kind of hard to do this with database mirroring. The other thing I should mention is it doesn't seem to scale as well as availability groups do. So also, it's not just that your 10 databases don't fail over together, but I don't know if I use it for that many databases on an instance. You don't see this set up very often, but it was possible to do automatic failover with database mirroring if you wanted to set up a third instance whose entire job is to witness and kind of handle that failover for you. And again, we're still kind of reviewing SQL Server approaches. We haven't talked about the any Postgres stuff quite yet. Next option up, you don't see use, but it's important to cover because it's out there. It's basic availability groups. This is basically the answer to the fact that availability groups are not available in standard edition. Bags are. It's basically kind of a dumbed down availability group that only works with 2 servers and it can only hold 1 database. So if you have a standard edition instance and you want to make it highly available and you want to use bags to do it, that basically means you'd have to set up 1 bag for each database and do some kind of work to automate the failover portion of it. I might mention this in passing when we get to the Postgres, or we're talking through Postgres later. However, I think that's really the reason you don't see basic availability groups used too often because, the way I describe that, like if you need your databases to fail over as a group, you have to do all this custom coding. It's on one hand, if you need the automated failover, you need minimal downtime, and it's important for the business that there's like money on the line. This is usually the point where management signs off on just using Enterprise Edition because it's like worth the money to not have to worry about this stuff. At the other extreme, if it's not that important, if you can handle having to like mess around with the failover a little bit, then there could be the sign you don't even necessarily need a basic availability group, and you could go with like some other approach to do it if you have to manually intervene anyway. Yeah, so I don't see these used very much, but they are out there. What you do see more often, what you do sometimes still see in standard edition are failover clusters. So a 2-node active passive failover cluster worked fine in standard edition. It still works fine in standard edition. You could do more complicated build-outs in enterprise edition, obviously. You don't see these too much anymore. A big part of the reason is they required shared storage, and kind of everybody, I shouldn't say everybody, but more and more people are in the cloud nowadays. This is getting better, but in the past, it was really hard to do shared storage in the cloud environments. I should also mention the actual cluster setup is kind of icky. So people are happy to not have to mess with it nowadays. Um, and there's also the issue that the cluster only has one copy of the data, so you have a little bit more of a possible single source of failure situation than you do with availability groups. Um, okay, so I talked through about 4 things you don't see used as much, and we're finally up to the part that's kind of like what everybody does in SQL Server, which is nowadays availability groups. Full on, always on availability groups are an enterprise edition only feature. Um, the big thing that you get for smaller shops that might only need high availability for 2 servers, the big thing that you get with AGs is really that the databases fail over together. So if you add all the databases in your instance to the availability group, something happens to one server, you don't really have to do anything special to be sure that they kind of all go to the secondary at the same time. There's both a synchronous and an asynchronous mode. You'd have to be in synchronous mode to do any kind of automatic failover, but the same availability group can have synchronous and asynchronous members, so it can do both high availability and disaster recovery using the same technology. You can also do readable secondaries. However, it gets a little bit expensive. In other words, you can actually connect to the secondary, do some queries. But the reminder there, and this mostly matters because they're comparing SQL Server to an option that has a free license. The main thing that matters there is you have to have a license for your secondary. And since we're talking Enterprise Edition, you have to really want to query it before you pony up the cache, typically. Um, and this, it's easy to forget about this, but a really, really cool feature that, again, they just tend to kind of do in configuration, not think about in the future. There's the listener, which is kind of like a network name that always points at whichever node is online. That's kind of built into the availability group, and to some point extent, it's just sort of like assumed it'll be there, so you don't have to worry about who's online, who isn't online. You don't have to worry about having, okay, except for some cloud environments where the networking is a little bit different. You usually don't have to worry about having like a load balancer in front of it to figure out who's active, who's passive. It just kind of yeah, the network name is just always kind of pointed in the correct spot. So that was our review of how we're used to think about things in SQL Server. So with every SQL Server presentation you hear, typically at some point you say, how do you do this? And the answer is always, it depends. The interesting thing I think about the high availability and disaster recovery option is if you're talking about a smaller environment where you just need, basic high availability capabilities for like one instance, and you need some kind of disaster recovery situation. Beyond a certain point, I don't think we think it depends. Like, this always kind of ends up being the answer. And talking through what's in this illustration, in the SQL Server world, when you're dealing with, small, maybe up to medium-sized companies, they don't need like a read scale availability group situation with like lots and lots and lots of reporting servers. You kind of always end up with a primary node and a secondary node in a high availability kind of setup with synchronous members. You have like another node on the other side of the country, or if you're on-prem, maybe it's in the cloud someplace, that's an asynchronous member. You kind of always end up nowadays with a file share witness, or possibly a gosh, the Azure cloud. I'm blanking the terminology. Possibly a cloud witness, but that kind of looks a lot like a file share witness. And then we don't like to think about it, but there's this Windows failover cluster that's kind of in the background. Um, yeah, so yeah, I just find it interesting that this is maybe kind of the one area in the SQL Server world where we don't have like a it depends sort of mentality. We just kind of always do something that looks a lot like this diagram. Um, Yeah. And they keep hoping that Windows cluster in the lower left corner can go away. It's um, Which I mean, it's nice that we had clusters available to help us keep track of the primary, secondary, help us handle the failover. But at the same time, a lot of the really, really weird issues we can run into. So you don't see it often, but there's this weird corner case. I won't go into details because it's literally a different talk, but there's a symptom where under some circumstances, you can have someone come in, do the monthly Windows patching on a weekend. They reboot the secondary because that's supposed to be a safe thing to do. And the primary goes offline for a little bit because of something that's happening in the cluster side. Um, so um, yes, there's a little bit of baggage associated with the cluster, but we also haven't been able to get away from it in the Windows world. Okay, it is beyond time for us to move on. So first I'm going to talk about high availability disaster recovery that's kind of built into Postgres core. That's a really important distinction in the Postgres world because, I mean, for SQL Server, we have the SQL Server product, just kind of what's, in the box, not that it's actually a shrink wrap box anymore. And we're kind of used to all working inside those constraints. On the Postgres side, it's a little bit more open. It's kind of a different philosophy. In SQL Server, we're trying to off the product offers kind of like a feature-rich solution that doesn't just do database stuff, but also SQL Server agent as a scheduler. It also, used to have SQL Server Management Studio built in as an IDE. I know that's kind of been pulled out as a separate product now, but it used to always be part of SQL Server. It comes with reporting, it comes with ETL tool, et cetera, et cetera. On the Postgres side, it's a little bit different. It's open source as a project with fewer people. And more importantly, that's part of like an ecosystem where there's all kinds of other teams writing all these really, really cool specific tools to do specific things. So Postgres development is more focused on just doing a really, really good relational database engine. There's not an agent built in. You'll have an agent. There's one that's nicely integrated, but it's technically a separate project. And the same's true for some of the failover stuff. To get the same level of functionality we're used to in SQL Server, you do have to use some extensions. However, extensions are are really, really common in Postgres, and they're just kind of part of the way you do things. So that's what I mean. I say in Postgres core, this is kind of how far I could go if for some reason you weren't willing to look at the extensions. So the very, very first thing we talked about in SQL Server was replication. I made the point of starting to talk about is logical replication because on the Postgres side, you kind of need to be more careful about the terminology because the term replication without a qualifier could either refer to this or it could refer to something that's a lot more like the availability groups. So we talk about Postgres logical replication. It's essentially the same animal as we're used to dealing with as transactional replication on the SQL Server side. Except it does tend to be used a lot more heavily. It's gotten to be relatively uncommon to run into people still doing replication on the SQL Server side. It's still used quite a bit on the Postgres side. So similar to transactional replication, newer releases, so pretty much anything you'd be running nowadays, do support bidirectional replication. However, very, very much in the same way that we said this for SQL Server, it's not really a mainstream high availability or disaster recovery solution. You could use it to keep a DR site in sync theoretically. I think I'm sure there are people out there who do it that way, but there are better approaches to go to it. And largely for that reason, this is about as much as we'll talk about logical replication because it's not necessarily used as much from a HA and DR perspective. However, it is actually kind of important for like migrate and upgrade scenarios, possibly. Well, and we'll kind of mention that as a tangent later. But again, the upgrades in Postgres would be like a different talk, probably that would need its own hour. Okay. So probably thinking, yeah, great, thanks, Rick. You just talked us through something that you said explicitly we won't use. The list isn't quite as long as it was in SQL Server. We're kind of already getting up into things that are actually used all the time for availability and disaster recovery here. Um, Next thing I'll talk about is wall shipping. If you joined in this, or if you're watching this talk, I'm assuming you've probably heard of wall files before, but if you haven't, again, for a SQL Server audience, you can kind of think of a wall log as kind of like a combination. The wall stands for write ahead log, if you haven't gone through that before. A wall file you can think of as being kind of like a combination of the transaction log and a transaction log backup in SQL Server. In other words, on the SQL Server side, we have the transaction log. If we're doing really any kind of high availability or disaster recovery stuff with it, it will be in full recovery mode on the SQL Server side, which means you have this kind of, think of it as a fixed size file. It's fixed size until it starts growing. You have basically a fixed size file that fills up with basically like journals of activity against the database. And then you have to go through periodically and back that transaction log up to file so that you can clear out the space and reuse it. So on the SQL Server side, the transaction log is like a fixed chunk of space that gets reused over and over and over and over. And for that reuse to there's a separate file you have to create, which is like a backup of those transactions that you can hold on to for a couple days in case you need to restore to a specific point in time, or better yet, ship off to your favorite cloud storage provider someplace or something like that. On the Postgres side, it's a little bit simpler because it's more like you have these wall files. They're used for the same kind of thing. So as activity is coming into the Postgres instance, you're basically kind of journaling all the activity into this wall file. However, when it gets to a certain point, Postgres decides it's full and it automatically closes off the file and just moves on to a new file on disk. And then there's a separate process that will kind of age them out and clean them up. Or better yet, send them to an archive so that you can access them if you need them farther back. um, so it's interesting how different that is. It's obviously kind of nice that you don't have to configure transaction log backups on the Postgres side. I I might dwell here just a little bit because I think it's kind of those important like mindset kinds of things to think about. In other words, why are things so different here? I would actually argue if SQL Server was being written from the ground up today, without, sorry about the barking. If SQL Server were being written from the ground up today, without kind of the long history it has, I don't know that things like transaction log would work exactly the same way it does now. Part of that's because I think so full disclosure, I've been doing this for like 25 years. My first SQL Server projects actually were not, Microsoft SQL Server. It was actually Sybase SQL Server on like old AIX and DEC Unix environments. And a lot of the product kind of actually worked the same all the way back then. One thing that was really, really different is at the time period, I was kind of young, so I don't know if this is really true or not, or if we just thought it was true, but there is at least a perception that adding a file system on top of a disk really, 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 really slowed things down. Um, so SQL Server, Sybase SQL Server at least, used to be able to just talk to a raw device. Like you just take a disk out of the box, essentially, hook it up, set up as a device on Unix, and say, create my transaction log on this disk. And SQL Server kind of run all the storage itself. I think that functionality is part of why the transaction log works the way it does. Because in that scenario, you have a raw device, you're just using the storage directly, you're not really making files, so it's not really a way to like make a file, close it out, and move on to the next one. You sort of have to get into this habit of cleaning it up periodically so you can reuse it. In other words, one way to express that is that SQL Server if we, anthropomorphize a little bit, SQL Server doesn't really trust the operating system completely. It likes to do things itself. It likes to do its own storage. It likes to do its own CPU scheduling, et cetera, et cetera. Like there's an entire, it's literally called SQL OS, basically operating system built in as part of SQL Server. Postgres doesn't do that. It trusts Unix to run the storage. So there's that entire like level of abstraction that we're not dealing with. Um, okay, possibly more than you wanted to know about the difference between transaction logs and WAL files. Getting back to the presentation. So we have these WAL log files that are kind of constantly getting written, closed out, and in most environments shipped off to some kind of cloud storage to access later. Um, it's very, very much like a transaction log, so we can ship them the same way that we do log shipping in the SQL Server side. So what kinds of um, I won't go through the details of how to set that up for the purposes of this talk. However, things to think about when you're doing this, there is an archive timeout parameter. In other words, you can configure how long Postgres will keep the WAL files around before it deletes them. If you probably, for most people, especially if you're just starting out, I would argue you probably should not be doing Postgres on-prem. It nowadays makes a lot more sense to do this in the cloud. However, if you were doing Postgres on-prem, like say you just could not use the cloud due to data security or just regulation, just really, really hard corporate rules or something like that. If you're in like a completely air-gapped on-prem environment, this archive timeout parameter is extremely important because, you have to set it big enough to be able to go back and um, restore data in the event of a crash. It matters, I mean, it has to be big enough. It matters a little bit less if you're archiving your files to cloud storage because you should just be able to go to that storage and pull back the files if you need them. But anyway, how much is kept locally is controlled by the archive timeout. Um, so in SQL Server, we can actually log ship from an earlier version of SQL to a later version. So if we're doing a rolling upgrade through a SQL Server environment, we can actually kind of update our secondaries, either async or synchronous, and log shipping and the availability group will kind of keep working fine. We don't pass a point of no return until we do failover. It's not really that way in Postgres. So in my slides, I say there's no hard guarantee about shipping between versions. I've been told by several people that's actually a drastic understatement. If you read the Postgres documentation, I forget the exact wording, but there's something to the effect of like, the developers will make an effort not to break the internal file formats between releases. People ever in practice, it's actually pretty common for the file formats to be different, and it's just really, 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 really unusual to be able to log ship between versions in Postgres. Which basically means upgrades are a little bit more dicey. And I kind of mentioned in passing that replication, even though it's not really a high availability or disaster recovery tool, you do see it used more in Postgres. This is part of the reason if you're doing a rolling upgrade through a Postgres environment, you actually, I mean, if you can't do the easy way, if you cannot actually do it by just taking everything offline, running the upgrade scripts, and then turning the thing, and then bring stuff back up afterwards. If you have to do a minimal downtime rolling upgrade kind of scenario, unfortunately, logical replication is kind of actually the way people end up having to do it if you have to mix versions. Okay. And of course, much like SQL Server log shipping, WAL shipping is kind of asynchronous. In other words, if you're depending on shipping a file from the primary to the secondary, obviously whatever happened to the primary between the time the file was completed and the time it crashed would be lost, which is part of why, yeah, it's not the real reason that this isn't a high availability, but it kind of makes it even more so, like not a high availability feature, is fine for disaster recovery as long as you're careful about your recovery point objective. Cool. Okay, so we're not going to actually crawl through the configuration file because I think that's just too detailed for this talk. But like high level, you have two servers, you want to set up wall log shipping. How do you do it? Oh, the first is that just like in the SQL Server world, the servers really ought to be the same. Ideally, they should be the same size. All the configuration settings should match, not just, the HA and DR settings. Like everything should be as close as possible. To get them into sync initially, you typically start with what's called a base backup. Um, well, there's a couple ways you could do it. So the real answer, most people use a base backup. The kind of old school answer would be if you're setting up a new instance and you're not adding something to an existing one, you could take some downtime. Um, Kind of the old school approach to this would be to, shut down your primary, copy all the files under your Postgres instance over to the secondary. Then you could turn your primary back on. Of course, the reason for the shutdown is to get a point in time consistent image of the disk. So base backup essentially gives you a consistent point in time copy of the stuff, or at least close enough that the Postgres past crash recovery can fix it. But it does that without actually having to take downtime. So it's as close as you can get to kind of a backup and restore in the SQL Server world. Except the base backup is kind of at the instance level. So the entire instance comes over. It's not just one database. Okay. So we deploy two new servers. We make sure all the configuration settings are the same. We take our base backup to make the secondary a kind of a copy of the primary. And then we just drop a standby.signal file in the secondary. That can literally be just the Unix touch command to just create the file. And the existence of that file is what tells the secondary that it is a secondary when it comes up. And then last part of this really should have been done in the initial configuration of the primary because, again, they should match. But really, the secret sauce for wall log shipping is that the restore command set up in the Postgres configuration will tell it where it can go to pull down the wall files to stay in sync with the primary. So once the standby.signal file is there and the restore command is defined, the secondary should be smart enough to detect when the primary makes a new wall file available to it, go out, grab it, and restore it to stay in sync. So there aren't quite as many moving parts with this as there are with standard log shipping in SQL Server, but like conceptually, you're doing the same kind of thing. Okay. So that was log shipping. Again, that's a great way to do disaster recovery. So then the question becomes like, how about high availability? So spoiler alert, part of the answer here is that to really do high availability, you need an extension. So remember for this section, I was staying like away from extensions and just talking about kind of native Postgres functionality. However, you can get, without extensions, you can get up to the point of something that looks like a read scale availability group. In other words, a primary with like a bunch of secondaries that are in sync with it that you can query. And the way that you get to that point and the way that you eventually take the next step towards automated failover using extension would be what's called streaming replication. And this is the reason that we have to be so careful to refer to what we're used to thinking as replication as a logical replication, is to distinguish between that and the streaming replication we're covering now. Okay, so this is very, very, very similar to what we think of as, the always-on availability groups or old school mirroring, which means instead of having to wait for your records to go to a WAL file, wait for the WAL file to get shipped across and wait for it to get restored, there's just a connection open between the primary and the secondary, and information is just like pumped through it in real time as it goes into the primary. And this can either be done asynchronously or synchronously. In other words, you can either set up so that you're saying, I'm doing the high availability. I want these two servers to always be in lockstep. I want to be sure I don't lose data if there's a failover. So make this synchronous, which means it has to be hardened into both servers before the insert will return to you, as opposed to asynchronous, which is the information is getting pumped from the primary to the secondary, but we don't wait for confirmation that got there. We just kind of assume that it will get there eventually, and we move on to the next command as quickly as possible to avoid latency. Um, there is nothing quite like the built-in listener or automatic failover. Um, that's that's not to say that you can't fail over gracefully with these, even though there's not a listener built into Postgres. You can do something kind of like what we used to use for database mirroring. Prior to availability groups, with database mirroring, there's this thing where you could put multiple connections in the connection string, and that connection time SQL Server kind of like figure out which one of those two servers is online. That's kind of how it's done in Postgres, and it works well. Um, okay, so let's say we set all this up. We have streaming replication working between our servers. What happens when the secondary fails? So, I mean, for review purposes, what happens in like in SQL Server world when the secondary fails? So if you have an availability group and one of the secondaries just kind of goes non-responsive for a while, um, you don't typically notice commands failing on the primary. I mean, there's like a transition period where the availability group is like figuring out a secondary dropped off. We don't usually notice that so much. I think the main thing that we notice is that when our transaction log backups run in SQL Server, if one of the secondaries is offline, it doesn't truncate the transaction log anymore. So over time, we start to see this kind of constant growth through the transaction log. If it gets bad enough, the transaction log will eventually start growing. And if it gets really, really, really bad, the transaction log will eventually fill the entire disk and SQL Server will go down. Um, however, because of all that functionality, when the secondary comes back up, as long as the secondary comes back to life before SQL Server crashes, so before it gets so bad that the transaction log has grown, filled the entire disk, and the primary actually goes down, once the secondary comes back up, it kind of recovers on its own. So the information will get pumped back out to the secondary will get caught up, transaction log backups will start truncating the transaction log. You might have a massive transaction log file on the primary that you might want to shrink down afterwards, but it kind of self-recovers and you're okay after all that. How about on the Postgres side? I haven't said anything up to this point. So in other words, the default behavior is to not quite have the same phenomena where, you're building up an infinite supply of wall files. So what happens to the Postgres side if the secondary is off for a while? So if we're just talking streaming replication, so we're just talking about the connection between the primary and the secondary. If the secondary is off for a while, comes back online, we don't have to worry about our primary as much about our primary going down as we do on the SQL Server side. But if we don't really do anything special, we might have to reinitialize the secondary. Obviously, how painful it is depends on how big it is. So, kind of like the entry level position on this could be we have our we're using streaming replication. Our secondary is in sync with the primary. Secondary goes down for like an hour, comes back up. We could use a base backup to bring it back in sync. It's obviously not like fantastic. We'd like for it to be more automated than that. So yeah, there actually are a couple of fixes for this. One is that there's a setting called the wall keep size. Um, so if we want to be able to handle like a kind of a short outage without worrying about having moved on to a new wall file, not having the data descend to the secondary, this setting could be increased to just kind of keep more stuff available. In other words, it's a little bit like increasing transaction log size would be in SQL Server. Um, that's still kind of using like a definite limit, so if you configure things so that it's okay for your secondary to be down for like half an hour and then recover, and it's down for 2 hours, you could still be in the situation of having to reinitialize the secondary. In theory, um, we'll come back to the why that's maybe not really that as big of a concern shortly. Um, the other options is something called a replication slot. If you configure replication slots, this basically registers the secondary with the primary in such a way that the primary kind of does keep track of if the secondary has dropped off or not. And it does actually put it in that mode we're used to in SQL Server, where the primary will try to hold on to data until the secondary comes back on. Now, that's obviously very, very, very cool if you're worried about keeping your secondary in sync with the primary and making things as self-healing as possible. The flip side of that is this maybe not as cool if you're mostly worried about the primary being happy and healthy and kind of bulletproof, despite anything that's happening on the secondary, because it's putting you in more of a situation where the secondary can impact the primary. That's not bad. It's just there's two sides of the coin, and it's important to be aware of that. Um, and before I move on to the next slide, I should also mention one thing we can have on the Postgres side that's I wouldn't say we can't do it in SQL Server, but we cannot do it with just availability groups in SQL Server. There's this idea of cascading replication. In other words, if you need a truly heinous number of secondaries, sort of keep track of like a really, really massive reporting load, for example, you could have multiple layers of this, where you have a primary, you have like a couple secondaries that are getting the data directly from the primary, and then below them, there could be another layer of more secondaries kind of getting information relayed to them through that first layer. That's essentially going after the same kind of functionality we have with DAGs or distributed availability groups in SQL Server. Um, it's just kind of a little bit more explicitly tied up with how you set up streaming replication than DAGs are with the always-on availability groups. Okay, so we talked about what streaming replication does. So then the question becomes like, how do we set this up and get it started? Um, as with any kind of high availability setup here, the first step is the configurations on the primary secondary should be the same. The second step is we need to initialize the secondary to be the same as the primary. That could be a file copy, but kind of the shortcut is to just use the base backup command. We do the same thing where we put the standby .signal file in the secondary to tell the secondary that it is a secondary. I maybe didn't harp on this enough when we're talking about wall file replication. This is extremely, 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 extremely important because Postgres, if we don't have extensions involved, Postgres out of the box doesn't have anything to prevent split brain. So if you forget that step of the standby.signal file, you start out with split brain like right off the bat when the secondary comes up. To tell the secondary that it should be using streaming replication, there's a primary coninfo setting that we set up to point at the primary. And then the question becomes, how do we tell it if it should be a synchronous or asynchronous secondary? There's a secondary synchronous standby names variable that contains a list. And you can do a lot of configuration in here. Obviously, with what we were talking about before, if we just have, two synchronous replicas for high availability and like one async off somewhere else for disaster recovery, you just have the two server names and the synchronous standby variable. But if you had, for whatever reason, like 10 secondaries, and much the same way that in availability groups in SQL Server, if you had a ton of synchronous secondaries, You could tell SQL Server that you don't have to harden the changes to all of them. It is possible to say, no, only harden it to like 3, and then you can return from the insert command. You can kind of do the same thing here, where if you had a really, really long list of synchronous secondaries, you could have, say, like first to say it only has to go to 2 of them, etc. Okay. So high level, um, that's those are the most important like high availability DR concepts in Postgres. Remember, we had a pretty long list of things we could use in SQL Server, although when we got to the end of it, the answer was we kind of always just do always on availability groups. On the Postgres side, it's kind of a shorter list that we have the wall log shipping, and then we have the streaming replication. Um, so if you were doing on-prem Postgres, and again, I wouldn't recommend it, but if you were doing this on-prem and you were managing all of this yourself, what kinds of things would really, really, really mess you up if you've been doing SQL Server for like 10 years and you come into this? The biggest thing is that promoting the secondary in Postgres is not a failover option. So in SQL Server, if we connect a secondary replica, say, alter availability group failover, that secondary replica comes online. The one that used to be the primary goes not offline, but drops into secondary mode, and we fail over the cluster. Remember, failover is not built into the core product in Postgres. So when you connect to the secondary node and you promote it to primary, if the primary node is still there, you've just given yourself split brain. There's actually, I don't think I threw it in the slide. In the Postgres documentation, when they discuss failover, there's actually a term, shoot the other node in the head. That's I consider an important part of the failover process is you promote the secondary and you do something to be sure that the primary will not come back online. Otherwise, you have a split brain. There's no built-in listener. However, you can specify multiple host names in the connection, and kind of out of the box without doing anything funky with the networking. This tends to work a little bit better in Unix environments than it did in Windows. So we don't run into some of the problems we can see with things like multi-subnet availability groups if we have multiple IP addresses registered with DNS. It's really, really pretty good at figuring out which one's online. No automatic hosts fail over the host fails. Again, this is core Postgres product. People do configure automatic failover. It's just you have to like pick an extension to do that. There's no built-in split brain detection or prevention. Again, kind of corollary of that first point that promoting the secondary does not cause a failover. It just gives you split brain. And this last one I mentioned just because there's 2 or 3 things, and I personally think they're not the things that you would expect that tend to make it really, really hard to migrate SQL Server workloads to Postgres. One of them is as long as we're talking about secondary replicas, there's no way to create a temporary table on a secondary in Postgres because there's not really a temp DB in Postgres. You can do temporary tables, but they're kind of like in the database. That mostly matters because if you're using readable secondaries for reporting purposes, it's not totally uncommon in SQL Server world to have like a stir procedure that does like a temp table so that you can break up the query into 3 or 4 parts and not, break the optimizer's brain and kind of aggregate the results in the temp table and return that at the end. That would not work in Postgres. Okay, so those are the things that would kind of mess with your head a little bit. Are there any pleasant surprises? Well, yeah. The big one for me is that wall log shipping and streaming replication can be combined. I know it'd be hard for me to that sounds like a really, really minor thing, but as someone who kind of handles the more gnarly problems when they come up, it's kind of hard to overstate how cool I think this is. So if you bear with me, on the SQL Server side, this isn't super common, but it's not totally unheard of to have a situation like, it's 5 o'clock on a Friday. Somebody does like something stupid and accidentally drops a huge file on the temp log backup drive or something like that. Um, you know, 7 or 8 o'clock in the evening when everyone's gone home for the weekend, transactional log backups suddenly start failing. Um, let's say in this scenario, the monitoring solution isn't necessarily 100% there, so nobody's getting notified that this is happening. So kind of quietly, Saturday morning, the transaction log file starts growing. And then nobody notices until Sunday afternoon. The transaction log file is within like, a couple of gigabytes of filling up the disk. At that point, SQL Server will go offline and there would be a business outage. And, we can't afford that. So what do we do? In the SQL Server world, the answer is typically, if you're really in that much of a hurry, like eject the secondary from the availability group. Um, do a transaction log backup if you can, but if it's an emergency situation like that, more often than not, someone might end up just switching to simple mode just to clear it out to stay online. And then, let's breathe a sigh of relief. Production stayed up. We're still handling transactions, but like, how do we get the secondary back in sync? For SQL Server, the answer is usually like, especially if you had to take that step of going to simple mode and back into full mode, the answer is usually that you have to like totally restore the secondary from scratch. And if it's a multi-terabyte database, that can take a bit. When we say that on the Postgres side, we can actually combine the wall log shipping and streaming replication, that means if you have that scenario happen where the secondary is not able to update itself for an extremely long time and gets totally out of sync with the primary, if you have the secondary using streaming replication, but it's also pointed at your archive storage for wall log files, when the secondary comes back without us having to do anything, it's actually smart enough to say, okay, I can tell I'm behind the primary. This is how far I caught up before. I'm going to connect to the cloud storage and start pulling in wall log files and get myself caught up until I can sync back to the primary. So you have a much, much more graceful refresh scenario. In other words, the SQL Server equivalent to this would be kind of like if the secondary was smart enough to just kind of go find transaction log backup files, start applying them on its own until it got close enough to the primary, and then finish syncing back up. So yeah, I obviously think that's really awesome because I probably spent way too much time on it. As I've mentioned like about 20 times through the course of this topic, the platform as a service or software as a service cloud implementations for Postgres work really, really well. We're kind of used to avoiding them in the SQL Server world. That's not as much of a thing in the Postgres side. You don't see as many on-prem installations nowadays because people have just kind of gotten used to doing all this stuff in the cloud environments. Um, and yeah, the double-sided coin. I mentioned before that there's not built-in split brain control. The flip side of that means that we have a lot more decisions we can make, a lot more control over how quorum and split brain things kind of work. In other words, I didn't do a good job of like expounding on this, but in the beginning, when we had that slide of like, this is how we do things in like all environments, and we always end up with this, kind of diagram and the SQL Server side. I kind of made a passing reference to like the Windows cluster can be kind of annoying. Um, the things that I don't like about how Windows clusters do quorum, like in the context of a database server, could be done differently in the Postgres side because we're relying on an extension that's not necessarily built in to do it. Okay. Okay, so that's how far we can go with the core product. What do we have to do to get failover to actually work on the Postgres side? And the answer is, again, you have to install some extensions. I haven't really added demos of these yet because the demos would have just been super time consuming. But I'll list through what the more popular options are. The first one that always comes up is one called PG Auto Failover. Um, This is really just a Postgres extension that keeps track of the health of all the instances. And it's a lot like in the old days of database mirroring, we used to have a witness server that would handle the automated failover between our two mirrored database nodes. That's kind of what PG Auto Failover does. You set up a new server, and its job is to just kind of monitor the instances, keep track of their health, and if one of them goes down, pick a new primary. Why is this first on the list? To some extent, I would say if you were doing this on-prem and if you're a smaller organization, this might be a good one to look at because there's less complexity than with the other options, and it kind of works fine for a two-node setup. It's maybe less appealing for bigger setups. So there's less complexity than the other options we have. And also for the SQL Server mindset, it's actually really, really intuitive. If we think about, for those of us who remember database mirroring, if you think about how database mirroring used to work with a witness, this kind of makes sense. The disadvantages, it doesn't really give you all the functionality that we're used to in availability groups, but the bigger disadvantage is possibly the monitor is kind of a single point of failure, by which I don't actually mean that if the monitor server goes down, you're you lose the ability to connect to the primary. It's more that if you have like say 4 replicas involved, if the monitor goes down and your primary goes down, you're kind of offline. Or if you think about how availability groups work, we have this dynamic quorum thing so that if you had a 4-node availability group, you lose your primary, and then 5 minutes later you lose the new primary. Node number 3 will still pick up the slack. But again, that's not really a consideration if you only have 2 nodes involved in your failover. So that's kind of the easier option. Kind of the more powerful, more popular in the larger corporate environment option is called Patroni. Basically, in a Patroni cluster, each instance has their own agent installed. The agents kind of share health information with each other. So in terms of how that works, it's a lot more similar to what we're used to with the Windows cluster, where each node is kind of like checking in with the cluster host over time. If the leader goes offline, a new leader is elected. So the cool thing about this is it's distributed. So if you have, going back to the example I just had, if you had 4 nodes involved, you lose a primary. Then a little bit later, you lose the second primary. The Patroni cluster will stay up, like an availability group would in SQL Server. Disadvantages, it's way more complex than the other option we talked about. And it doesn't really do a direct like network communication where everything keeps track of all the information in memory. It actually relies on using a distributed configuration store to communicate between the nodes. In practice, most organizations that are looking at doing Postgres and are looking at doing the high availability and are looking at doing Patroni have that anyway. But if you're kind of starting from the ground up, that's one more thing you have to get installed and get working and make sure it doesn't break for your high availability to work well. Other options. So there's always the cloud. There's another package I didn't discuss called Rep Manager. That's kind of an alternative to Patroni, but it doesn't have the same kind of market share. All that said, also we're talking about Unix, especially. So for a lot of use cases, rather than doing failover this way, containers may be an easier option. Literally different talk. This is actually a good reminder. There's somebody I need to bug to send us a abstract on this stuff. But yeah, so containers may be an option. And then there's another one you hear mentioned. I didn't give it a slide because I don't really consider it an automated failover tool. But there's a library called pgPoolTool, which is so in SQL Server, connection pooling is kind of there by default. It's actually built into the drivers. You kind of have to turn it off if you don't want it. In Postgres, connection pooling is kind of like a separate thing. There's a library called pgpool that does connection pooling. It's not meant for failover, but one of the things they can do is like that can be configured in it is it can kind of it does have some functionality to pick a primary in terms of like which server it points connections to when they come in. So kind of almost more like a proxy functionality than what I might think of for pooling. Here are a handful of references going through most of the information I talked through. And with all that, I'd just like to say thank you for listening, and I hope this is helpful.
This was fantastic. I am rusty and out of touch on Postgres. So this has been a really good primer on all of this stuff. So thank you. If anybody's got any questions, either drop them in the chat window or come off mute and love to say hi. And while we're waiting, if there's anybody that's watching this after the fact, do not hesitate. Reach out to Rick, reach out to us here. Give us your questions. There's never a sales or marketing pitch, and we're just here to help.
Yeah, I wanted to thank you, Rick, and both you and David on for putting this together.
Oh, yeah.
You're
Yeah,
welcome.
I love talking about this stuff.
Yeah, a lot of fun. SQL Server is a great DBMS platform, but it's not the only platform out there. I do a small amount with Postgres. I want to do more. I know Rick has been venturing into that area quite extensively, and that is fantastic. Cool. Well, if there's no additional questions, Rick, thank you. We really appreciate it. If you're watching this after the fact on YouTube, one, thanks for taking the time out of your day to watch, and let us know if there's any questions at all with this. And we will see you on the next one. That is going to be October 14th with Tim Bradney talking about Azure Data Security as it relates to HADR. So thank you very much.
That's okay.